Hello everyone, welcome to Algebra 2B Live, a week 8 video starting with trigonometry and ratios. For week 8, make sure you're going over all the recordings, going over the paper pencil problems, going over the multiple choice quiz, and anything else I got for you this week. Let me know if you have any questions on any of the assignments. For our objectives this week, what we're going to be doing is starting everything with trigonometry. If I give you a right triangle, it's a lot of our focus today. If I give you a right triangle, use trig ratios to find unknown side lengths, and then use inverse trig ratios to find unknown angles. Apply right triangle trigonometry to solve a variety of problems. This will be kind of a little bit of geometry review here for you guys. And then we're going to get into trigonometry patterns and angles on the coordinate plane and a unit circle. We talk a lot about unit circle and measurements in degrees, and then learn about radians as a way to measure angles as well. So some good stuff. Should be some stuff that you've seen before in geometry, but that's where we need to start and get really rock solid in our triangles and trigonometry. So that's what we got going on the rest of the semester is trigonometry. 5 weeks of it. We're going to get into a lot with graphs, a lot with angles. There's quite a lot with trigonometry. It's really fun to dig into it. Hopefully you guys are looking forward to it as well. Trigonometry functions relate angle measures in right triangles with their side lengths. But let's take a look. Just to give you a sneak preview, trigonometry is useful anytime we have data that's periodic or that repeats. So oftentimes we can use trig functions to model climate patterns. If you think about the weather, here's a Portland climate graph. In January, it's cold, right? Graph's low. It warms up into the summer and gets hot, cools back down when it gets into the winter, and then guess what it's going to do next year? It's going to repeat. It's going to keep waving up and down and up and down and up and down. We could represent weather and temperature with a trigonometry function. What about music and sound waves? Well, these are kind of nice wavy periodic graphs, right? These are all representative of sine functions, and we can combine some functions in different ways to even make this third one a composite wave. So anytime we have sound or light or magnetic, anything that can be modeled with a wave, we can use trigonometry functions for that. So any data, again, repeating myself, but any repeating pattern of data, we call it periodic, and we can use trig functions to model this kind of data. Let's dig into what trigonometry is about. It starts with a triangle. That's where you start with, trig triangles. Every triangle obviously has got 3 sides, and it's got 3 interior angles. As we're working with this trigonometry, we're going to be working with right triangles. So you see this little symbol right here. It means you have a 90-degree angle, which means you also have this angle right here, and you have this angle right here. These 2 angles, angle A and angle B, have to add up to 90 as well. All 3 angles add up to 180 degrees. But we're going to be doing a lot with the ratios, or how all these sides relate as well. 3 sides on a triangle. Mathematicians wanted to relate the side lengths with the angle measures, so they came up with trigonometry functions. Here's your 3 basic trig functions that we're going to start with. You have sine. And when we have the sine of an angle, it just means in terms of it relates the angle of the triangle with its opposite side length divided by the hypotenuse side length. So if here's my angle measure right here, the sine function relates the opposite divided by the hypotenuse. If I have a cosine function, the cosine function takes any angle and it relates the adjacent side with the hypotenuse. So there's my angle. But if I have the cosine, now I'm relating these 2 sides together and finding a ratio. Opposite hypotenuse, adjacent hypotenuse, the only one left is tangent. And guess what tangent relates? It relates the other 2 sides together. It takes our opposite side and our adjacent side and divides those. So again, it's connecting your angle measures in a triangle with the side lengths and being able to write equations. These are all equations with equal signs. So here's a website. Let's take a look about how changing the triangle and changing ratios actually affects trig values. I'll pull this up here. All right, here we go. We got a GeoGebra site here. I love GeoGebra for understanding. There's lots of great things where people put together different diagrams to show you. So here we got a right triangle. I've got 3 side lengths. And then I can play around with adjusting side lengths, right? I can make C, I can change the triangle this way, but I can make it bigger or smaller as well. So let's make C small. And so this angle measure right here, right now it's only 6.78 degrees. That's really small. As C gets bigger, the sine value right now of that angle is pretty small. It's taking the opposite side divided by the hypotenuse. My opposite side is really small, so my sine is really small. It's 0.13. As I make this red side bigger though, watch what happens to the sine. The ratio changes. This opposite side divided by the hypotenuse side, 2/6, almost 2.5/7, the ratio is going to change. If I change it, keep making it smaller, if I keep making it a bigger ratio, now sine is getting bigger and bigger. The opposite side divided by the hypotenuse side is now 0.8. Now the ratio, the biggest it can be is 1, and that would be that this side and the hypotenuse side are the same length. To be in a triangle, you can't even have it that way. So it's going to get close to 1, but never quite reach 1 because you can only get so close. Like right here, if I make this side really small, that's really close to 1. These two sides, if I divide them, are really close, but they're not, it can't ever be greater than 1. Okay. So there is, oops, make it smaller. So again, trigonometry is the ratio of sides. We're just looking at the sine, so it's the opposite divided by hypotenuse. Now let's do, if I make, notice what doesn't change, however, is when the triangle is bigger or smaller. As long as the angles stay the same, your sine is going to stay the same. This is a really big triangle. It's 4.87 divided by 10.93. Same angle, so it's going to have the same ratio. If I make it really small, 1.67 divided by 3.76, same angle, so it's going to have the same sine. But there you go. That's what we're doing. We're relating different functions together. Okay, so how can we use this? Well, the first thing to start with is we can find unknown side lengths. So let's come up with a triangle and some side lengths that we don't know here. It's going to be a right triangle. And let's see, let's say this is 28 degrees right here. And let's say the hypotenuse has a side of 12 feet. We'll give some units. Let's find out what are all the other sides and angles based on our trigonometry. So we only know 28 degrees, it's a right triangle, the hypotenuse is 12 feet. Let's find all the other sides. So the first thing I know is all 3 angles have to equal 180. These two have to add up to 90. So if I take 90 minus the 28, that means this side here has to be 62 degrees. There you go. Now we've got all 3 angles. This is my hypotenuse. I'm going to go ahead and label this. I'm going to make this my main reference angle, which makes this the opposite side, OPP, opposite, from 28 degrees. And that makes this side the side adjacent to it. So I'm labeling opposite, adjacent, hypotenuse because it makes a big difference in terms of which trig function I use in relating this 28-degree angle. Let's solve for the adjacent angle first. I know the hypotenuse, I don't know the adjacent. Which trig function uses the adjacent and the hypotenuse? That's going to be the cosine function. So the cosine of 28 degrees has to equal the adjacent side. I'm just going to go ahead and put ADJ. I don't know what it is yet. Has to equal the adjacent side divided by 12. All right, look at that. That's an equation. How can we solve that? Well, I'm going to multiply both sides by 12. It divides out there. So the adjacent side has to equal 12 times the cosine of 28. Well, how do we calculate that? I'm glad you asked. Let's pull up our Desmos calculator and do some trig functions in there. All right, here I am, my Desmos calculator. We need to calculate 12 times the cosine of 28. Let's pull up my keyboard here. I got it pulled up. We're going to go to functions. And we have a whole tab for trig functions. Here's my sine, cosine, and tangent. We're going to learn about all these other ones here in a little bit too. But I need the cosine of 28 degrees. I'm going to put 28. Now, there's something we need to be careful of. It'll make more sense in a little bit. When we deal with trigonometry, we deal with different types of things. Notice this is telling me, oh, that's equal to negative 11.55. That doesn't make any sense. To have a negative 11, we're looking for a side length. So come over here to our settings. This is 28 degrees. So what I need to do is make sure then that I'm dealing in degrees. So I gotta click degrees, and notice this number changes. Now it's 10.59. That seems more reasonable for a side length. At the end of this class, we're going to talk about radians, and as you use your calculator, based on what you're trying to calculate, you need to toggle back and forth between radians, if you're using radian measures, or degrees, if you're using degree measures. This is a degree problem because 28 is degrees, so I need to make sure I'm on degrees. And there we go. 12 times the cosine of 28 degrees is, I'm going to round it to 10.6. Call it good there. Okay, so because I switched sides, I lost all my notes. This was 12. This angle was 28 degrees. And we just solved that this angle was 10.6 degrees, or 10.6 feet. And we know this angle has to be 68 degrees because they have to add up to 90. This is our 90-degree angle. Okay, we still don't know what the opposite side is, right? So we use the hypotenuse to find the adjacent side. I know the adjacent and the hypotenuse, but now let's solve for the opposite side. So with the opposite, I'm going to use the opposite and the hypotenuse together. And this time I need to use a sine function because sine relates those two sides. So the sine of 28 degrees has to equal the opposite side, which I don't know yet, divided by 12. But to calculate it is the very same exact way. So let's go and now let's calculate the sine. I'm going to multiply both sides by 12, so I need 12 times the sine of 28 degrees. All right, here I am. My calculator, I'm just going to change cosine. I'm going to type sine, and there's 12 times the sine of 28 degrees, and it's I'm going to call it 5.6. It's okay, we're rounding it to the nearest tenth. So let's go back and fill in the rest of our triangle. So we have now successfully solved for everything. All we knew at first was it was a right triangle marker. We knew the hypotenuse was 12. We knew this angle was 28 degrees. And just based on those things, we were able to find every other side and angle measure of this triangle. It's about approximately 5.6, and this one was approximately 10.6. There you go. That's using trig to find unknown side lengths and angle measures. Just like we have a function to get from the angle to the unknown side ratio, we also have inverse functions. Remember in math, we love to be able to do things and then undo things, adding, subtracting our opposites, multiplying, dividing our opposites, squaring, square rooting our opposites. We have the ability to cosine an angle, and we have the ability to uncosine it, or inverse cosine. Now, some things to keep aware of. We use inverse cosine with this little -1. That's oftentimes used in math for inverse. So there's cosine with little -1 in the power means it's inverse cosine. You'll also see arc cosine or arc sine or arc tangent. That's another way of writing inverse. Your Desmos calculator uses the arc cosine in that notation, but it means the same thing. Sine inverse, arc sine, those are the exact same things. It's easy to get kind of confused, especially when you're just starting out. So here's a problem about how we can use inverse trigonometry. So we use inverse trigonometry whenever we don't know the angles. So say we have a triangle. this side is 4, and this side is 19, and this side is 19.42. But I don't know anything about the angles other than it's a right triangle. So my goal is, how do I work backwards to find out then what this angle is? Let's call that angle A, and what angle B is. We're going to use some inverse trig to do that. Okay, so we're going to do some different things here. Let's find angle A first. And I know 3 sides. So find the angle measure. I'm going to use the side 4 and 19 just because I like nice whole numbers. And this is based on angle A, this is going to be my opposite side. And this is my adjacent side. The trig function that relates these 2 sides is the tangent. So I can write the tangent of some unknown angle has to be a ratio, though, of opposite divided by adjacent. So it has to be 19 divided by 4. That's how trig right triangles work. So we can work backwards now to find this angle. If I want to undo tangent to get the angle by itself, I'm going to take the inverse tangent of both sides. So my angle measure equals the inverse tangent of whatever 19 divided by 4 is. Well, let's go calculate that on our Desmos calculator now. All right, here we are. I need inverse tangent, so I'm going to go to my functions. There's trig, sine, cosine, tangent, and here is arc sine, arc cosine, and arc tangent. These are my inverse functions. I need the inverse tangent of 19 divided by 4. And what is it telling me? It's telling me that's about 78.1 degrees. That's my degree measurement because I'm still, remember, in degree mode. All right, so we just got our answer. That's the angle that if I take the tangent of that angle gives me that ratio. 78.1, let's go back to our triangle now. And we had, what, this was 4, this was 19, and now this angle right here is 78.1 degrees. All right, very good. Once I know that angle, then I can immediately just take 90 minus that to get this other angle, and I'm all done. So 90 minus 78.1, that's going to be 11.9. And this side was already given as 19.41. There you go. So now we've got all 3 angles and all 3 sides again. So we can use trig, we can use inverse trig to solve any right triangle. We can find as many sides as we want or angles as we want. Let's do a word problem involving some trig. I like word problems. Here we are. A ship's sonar spots a wreckage at an angle of depression of 32 degrees. If the depth of the ocean is about 250 feet, how far is the wreckage measured along the surface of the water from the ship to the nearest foot? All right, like any good word problem, we got to draw a picture. So here's my boat. It's on the water. Angle of depression means angle going down. So if the flat line is on the water, the angle of depression, 32 degrees, would be this angle right here. So that's 32 degrees, and there we see the angle. If it was angle depression, again, going down. If it was not, it's not going up. They're looking underwater. The depth of the ocean is 250 feet, so now we're given a depth. So that's our straight down, 250 feet. And the ship sees some sort of wreckage. That's where it is, on the ocean floor. All right, there's a picture showing what's going on in this problem. So now, what are we asked to find? We're asked to find how far the wreckage is along the surface of the water. So we're asked to find what is this distance. Remember, the boat wants to stop right above it, and then the divers can hop down and go down and explore. So that's where we're going. How much farther does it have to be before they are right on top of the wreckage? Well, let's think about it. There's my right triangle. There's my angle. I know one side. this 32 degrees, let's give all our sides. So this is the hypotenuse side. I'm going to label that. It's the long side. This is the side opposite by 32 degrees. And this is the side adjacent. The adjacent is the one I want to find. Okay, so now let's figure out how to set up my problem. I know the opposite, I want to find the adjacent, and I know the angle. So the trig function that relates the opposite and the adjacent is the tangent. So I'm going to have tangent of 32 degrees has to equal opposite divided by adjacent. 250 divided by our unknown length. Okay, to solve this one out, I'm going to multiply both sides by x, but then I have to divide both sides by the tangent. So what we end up getting is that our unknown value x equals 250 divided by the tangent of 32 degrees. Okay, so let's calculate that out. We go 250 divided by, let's pull up tangent of 32 degrees. It's 400, almost 400 exactly. Look at that. All right, let's go back to our problem. If I had my picture, we found this distance had to be about 400 feet. That's how much further the boat needs to travel. There we go. We used trigonometry to solve a word problem. All right, now comes the fun part. Everything we've done up to this point should be somewhat reviewed from what you did in geometry. You did triangles, you did right triangles, you did some trig triangle trigonometry, SOHCAHTOA, sine, opposites, hypotenuses. So now that we're solid in that, now we can start to look at the unit circle. So the unit circle, we're still about triangles. If you look on there, you can see a nice little triangle formed right here, right? Draw it in. There's my right triangle. There's my 90-degree angle. But now we're putting it inside a circle. We can take all the right triangles and we can now think about it in terms of, oh, there's an x value to the right triangle and there's a y component to the right triangle. And we can make all sorts of right triangles at any point along the circle. And so a lot of trigonometry is simply drawing the right triangle and thinking about the patterns we're seeing around a circle. I think there's some really bad right triangles, but I think you get the idea is that we can keep going around and draw these right triangles. So let's draw a ray at 15, 130, and negative 50 degrees. And we'll draw the reference angle in the right triangle. All right, so 15 degrees. If I think about my circle, there's 0. 15 degrees is going to be right about here. So the ray then is from the center to the 15 degrees. There's my ray, and there's my reference angle. So there's my 15 degrees, and I can draw a right triangle right here. There's a horizontal component to the right triangle and a vertical component. Let's draw another one at 130. So 0 degrees, if I go straight up, now we've got a 90-degree angle. And if I keep going, 130 would be right about here. So I'm going to draw this one in red. So from the center of the circle, there's my 130-degree angle. But the reference angle is from the horizontal line. So instead of going an angle all the way over, I draw a line straight down. And the reference angle is right here. This is going to be from 180 to 130. This is going to be 50 degrees right here. And then there's my horizontal component. And there's my vertical component to my right triangle. Now finally, we can draw one at negative 50 degrees. Let me get a different color here. Let's do magenta. Negative 50 degrees means I'm going in the opposite direction. I'm going to go backwards 50, which will be right about here. There's my ray. That's at negative 50 degrees around the circle that way. I can draw my lines straight up, and there's my reference angle right here at 50 degrees. There's my horizontal component of the triangle, and there's my vertical component of the triangle. Now you may be saying like, what? Where's the trigonometry in this? Other than right triangles, it just seems like we're drawing triangles and circles. We're getting to the trig. We're building up to the trig. But hang with me for a little bit more here. Some other vocabulary. So besides reference angles, we also have something called coterminal. Now, let me show you what this means. We want to find 3 coterminal angles to 250 degrees. Let's first find out, well, where is 250 degrees on the triangle? So on the unit circle. So right here is 0 degrees. If I go all the way up, straight up top, that's 90 degrees, because it forms a 90-degree angle there. Keep going around more, there's 180 degrees. That's halfway around the circle. All the way down there, straight down, is 270 degrees. And if I make one whole loop around the circle, we're back to 0, or 360 degrees. Coterminal just means it's this idea that if I go around the circle, I end up where I started with, right? I started at this point, which was 0, but I end up at the same point, and then I call it 360. If I go around the circle again, this is also could be thought of as 720 degrees. If I go around again, that could be thought of as another 360, which would be 1080. The same point on the circle has different angle measures. We can keep getting bigger and bigger, and it goes on and on and on. So to find coterminal, we add 360 degrees or subtract 360 degrees to go forwards and backwards one whole lap around the circle. So 250 degrees, that's going to be right about here. So there's our 250 degree angle. There's my reference angle right there. There's my, let's draw the right triangle. There's the 90-degree angle. There's the horizontal part. There's a vertical part. The reference angle here, if this is 250, that's 70 degrees from 180. So this is a 70-degree angle right there. But at 250, a coterminal angle would be 250 plus 360 degrees. That's going to be 610 degrees. That angle is the same angle as 250 degrees, the same spot on the circle. Let's add another 360 degrees. Let's do another lap around the circle. Well, it's going to be 970. This degree angle measure is going to be the same exact point as 250 degrees. So we've now got one coterminal angle, two coterminal angles. Let's take 250 minus 360. We'll go backwards. Well, that's going to be negative 110. This angle, if I start here and go negative 110, it's going to still get me to that same exact spot on the circle. So there's 3 coterminal angles, and there's actually an infinite number if you want to keep going on and on and on. We just add 360 or subtract 360. Now you're starting to get this idea of repeating pattern, right? Why we have the same thing over and over and over again, and why trig functions are used or often called periodic functions. Because when we go around the circle, we go through the same points over and over and over again. Lastly, another thing we need to learn as we're building up our ability to handle working with trig functions is a new way to measure angles. Degrees is nice. We know how to calculate with degrees and work in degrees. One full circle is 360 degrees, right? We got that. We just kind of worked with that. There's also a way to measure based on what we call radians. Radians have this idea that a circle has a circumference, and instead of the angle measure, we measure kind of the circumference or parts of the circumference. So the radian is based on a circle with a radius of 1. Now, if you remember, the circumference is equal to 2 times the radius times pi, right? Remember that from your geometry days. So if the radius equals 1, and I put 1 in for r, then the circumference equals 2 times pi. That's where we say one whole circle is 2 pi radians. So let's play around with this. We start at 0 radians. If one whole circle is 2 times pi, then let's think about fractions. Halfway around the circle is half of 2 pi, which is only 1 pi. So 0 pi, 1 pi, 2 pi, 3 pi, 4 pi. I think you kind of get the idea. 5 pi, 6 pi going around and around. So we can think in terms of halves. We have so many other angle measures. What about all these 90 degrees? So now let's think about, okay, if 2 pi, I could think of that as 4 pi over 2, right? So I'm changing 2 over 1 into 4 over 2. So now we have, that's one whole circle. So if 4 halves is one whole lap around the circle, so then we have 1 half is 90 degrees, 2 halves is halfway, 3 halves is 3 quarters of the way, and then 4 halves is 4 halves pi is one whole lap around the circle. And you can get smaller and smaller and smaller. Right here would be pi over 4 radians. There'd be 3 pi over 4 radians. There's 5 pi over 4 radians. 6, and then there's 7 pi over 4 radians. And again, notice all that we did was we broke it into fourths. 2 pi is the same as 8 fourths. 8 fourths is the same as 2, so we have 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths. We can break it down into 6, we can break it down into the thirds. We'll get more into that later. But that's where radians comes from, is the idea of one whole lap around the circle is 360 degrees. Or if I specifically make the radius of the circle 1, one full circle is 2 pi radians. Let's do a little bit more with that. So we have 45 degrees. We love 45-degree angles, right? That's kind of one of our special angles. Let's change 45 degrees, but change it into a radian measure. We're going to use ratios. We know 45 degrees divided by 360 degrees. 360 degrees is one whole lap around the circle, which is the same as 2 pi. So it should have the same ratio then as our unknown angle measure in radians over 2 pi. 360 is the total, 2 pi is the total, so we're finding to find the same ratio of the part. To solve this, it's just a cross multiplication problem, right? So that equals 2 pi times 45 equals x times 360. And you can quickly see if I divide both sides by 360, our unknown angle measure, we just take 45 divided by 360 and multiply it by 2 pi. Well, let's do that. I'm going to pull that out here real quick. 45 divided by 360. Whoops, hold on. 45 divided by 360 is 0.125. Multiply that by 2 and pi. I'm going to use 3.14 because I don't have pi in this calculator. Let me check that again here. So there we go. 2 pi times 45 divided by 360. Let's go to our Desmos calculator and calculate that out. All right, so we had a fraction. We have 2. On your Desmos calculator, we got a nice pi button right here. So there's 2 pi times 45 divided by 360. And what do we get? We get that that is 0.785. So using our calculator, we saw that we needed to do 2 pi times 45 divided by 360. And when we did our calculator, it gave us about 0.785. Now we had to approximate that. We had to round that. I don't know if I like that so much. Let's see what we can do in terms of simplifying it and making it an exact answer. So 2 pi times 45 over 360. Check this out. 2 times 45 is just 90. So that's the same as 90 pi over 360. But 90 over 360, I can reduce that down to 1/4. And so it just becomes 1 pi over 4. And there's our exact measurement. 45 degrees right here on this circle is equal to pi over 4 radians. Nicely done. Okay, so we did 45 degrees. Let's do 220 degrees. Again, same thing. 220 over 360 equals something over 2 pi. Trying to find the radians, I'm going to multiply both sides by 2 pi. And let's see if we can reduce it and find an exact answer here. So 2 times 220 is going to be 440 pi over 360. I can reduce that down. If I take away the zeros, that's 44 over 36. And if I divide it by half, that's 22 pi over 18. I can continue to reduce it by half to get 11 pi over 9. So there's my exact radian measure. 220 degrees is the same as 11 pi over 9. Okay, the final thing for today is the other way. What if you have radians and you want to convert it into degrees? We're going to do that again using a ratio. So this time I don't know how many degrees, x out of 360, but I do know it's pi divided by 4 over 2 pi. And so if I want to solve for x, I'm going to multiply both sides by 360. And then simplify it out. 1/4 times 360, or pi over 4 times 360, is just going to turn into 90 pi over 2 pi. And, well, the pi's divide out, and 90 over 2 equals 45. So there we go. We just turned pi over 4 back into 45 degrees. 90 divided by 2 is 45. Well, now let's do 4 radians. All right, so I don't know how many degrees. It's x out of 360 degrees. But it does equal 4 radians out of 2 pi radians. 360, 2 pi totals. Multiply both sides by 360. 4 times 360, 1200. 1440 over 2 pi. Well, that's going to turn into 720 over pi. And in this case, I can leave it at 720 pi, but since I'm not in radians, I'm going to go ahead and divide it and estimate it. So it gets me about, in this case, my angle measure, if it's 4 radians, it's about 229 degrees, approximately. I had to round it a little bit there. But in this case, it wasn't a nice pi radians. It was just 4 radians. So that's about 229 degrees. And we converted it over. To get 229, it did 720 divided by pi. Okay, so we did a lot today, week 8. We did a lot with right triangle trig ratios, inverse ratios, opposites, adjacents, hypotenuses, solved some problems. But then we started to get big picture, and we're learning a lot of vocabulary. We're learning how to work with the unit circle, drawing triangles around the unit circle, finding the right angles, coterminal angles, degrees, and radians. Stay tuned for next week, week 9, and we'll get jump right back into unit circles and start building our trig functions. Let me know if you have any questions this week. I look forward to seeing you guys later.